Uh, this video, I'm talking about evolution in mathematics. I mean, uh, basically, in the previous video, I talked about symmetry, I mean, type of symmetry that connects different versions of an axiom. And I said, for instance, if an axiom is evolving, there should be some type of symmetry that brings all those versions together. So in this video, I'm going to discuss the concept of evolution in mathematics. And the point I'm trying to make in this video is that evolution is not new in mathematics. And in conventional mathematics, it's something that mathematicians do all the time. So uh, to start, before starting, actually, I should say that things I'm saying in these videos are meant to be understandable for everyone. So I'm not going to talk about complicated mathematical ideas. I'm trying to make things as simple as possible. So I think you are familiar with this in school. And if you don't remember it, I hope you remember it as I explain. This is XY space. This is XY space. And this is, for instance, a vector, an arbitrary vector. So this vector is defined in this XY space. And to identify this vector in this space, I say this much of V is available in this direction, in I direction, and this much of V exists in J direction. So V is basically vector V equals, sorry, this much x1, for instance, x1 is a number, x1 is a number, and let me write it a bit more clear. This is y1 in the j direction. So the v vector is x1 in the I direction, in the x direction, and y1 in the j direction, in the y direction. So this is a number, this is a number. This much of V exists alongside the x-axis, and this much of y exists alongside y-axis. So this is a space. This is a very simple space, and this vector here is a very simple entity defined in this space. So we can generalize this and build on top of this concept and construct more abstract spaces. For instance, instead of straight lines, these x and y, instead of these straight lines, I can think of something more abstract. For instance, I theta. This is a wave, and it doesn't matter what it means, just consider it as a wave. This is a wave, and I can construct a space based on these waves. So, for instance, I can say f of x, some function, some entity in the space defined by these uh, waves, basically base vectors, bases, and I call this spaces. These things are not important. I'm just trying to be accurate, but it's not important. These are called bases. And instead of I and j, instead of this x and y, I'm now using this wave.